Now we can model the mezzanine floor in the ETABS software. So we can go to use built-in settings with metric SI, Australia. Steel section database is Australia, New Zealand. Steel design code can be AS4100 and concrete design code can be AS3600 2018. We can left click on OK. So after that, we can, open our or like assign the number of grids as per the requirement. So along X, we do have two grids of 6 meter equal spacing, and along the Y, we do have three grids of 4.5, 4.5, and 1.5. So number of grid lines in X direction, that can be 3. This can also be 3. Spacing of grids in X direction can be like 6 meters, and spacing of grids in Y can be 4.5. Number of stories, that can be selected as 1. Let us assume the typical story height is 4 meters. So we can left click on OK here. So we can say that our purlins are like running in this particular direction, and our main movement resistance frame is along this particular direction. So we can go to the define material properties, and in here, as we know that by default the thickness that is selected is between 11 and 17 mm. So we can left click on add new material, and in here we can select the, instead of AS3679, we can select AS1163 also, that is for the box section. So we can select grade C350 here, left click on OK. And we know that our design material property, the yield stress is 350 MPa. So we can left click on OK, and then again left click on OK. So after that, for modeling the eye girders, we already have this particular property. And then we can again left click on add new material. And in this basically ETA software, we don't need to design the C purlins as we have already designed in the X Factor software, but we do need to model them. So to model them, what we can do is that we can select 3678 2016, and for the modeling the properties, we can select T less than equal to 8 mm. Now you don't need to understand that it doesn't much matter as we are not designing the purlins, but to tell the software that there are these lateral restraint allow for all of these, we can say the hot rolled U beams, or sorry, I beams or uniform beams, we can model them. So both the approaches are done. Either we can proceed with the only the frame design, or we can proceed with full 3D design also. So in this particular case, that obviously the yield stress is higher, but again, that doesn't much matter to us. So we can go to the define section properties and frame sections. In here, we can left click on import new properties. We can go to the box section, and under the case of steel tube, and we can select the material properties as C350. So here we can select, let us say that we are proceeding with 150 by 150 by 6 mm. Yeah, here. So this is the box section of 150 mm and 150 mm size and 6 mm thickness. So we can left click on OK. So this we can assume it as the column sizes. And after that, we can left click again on import new properties. We can left click on steel eye section. So now default material, we can select this 300 grade, that is thickness between 11 and 17. So in here we can select 410 UB 53.7. After that, we can select, let us say, yeah, we can open the filter text option also. So only UB shall be visible here. So UB 410 53.7. After that, UB 360 44.7, and after that 310 UB 32. So instead of 53.7, we can select 59.7 also. So now that is okay, and we can left click on OK. So again, we can left click on OK. Yeah, but before that, we can again left click on add new property. So we can model the C purlin also in this particular case. So in here, we know what we can do is that total depth, we can take it as 200, total width. For that, we do need to open the document So for 200 into 1.9, our flange thickness is 72 and thickness is 1.9. So this we can select it as 72 and flange thickness we can select it as 1.9 and web thickness also we can select it as 1.9. As I said, this is just an indicative property which we are not going to design. So we can name it as C200 1.9 mm thickness. So again, we can left click on OK and then again left click on OK. So now we can go to the draw beam column base and we can left click on quick draw column option. Select all stories option here and property we can select it as 150 by 150 by 6. So we can just click on all of these intersection points here. Yeah, so we can left click here and then again left click on 3D here. So now we can see that we have modeled all of the columns here. So after that we can go to the draw beam column brace. In here we do need to select the moment releases as continuous because we are not modeling the simply supported beams. And after that we can go to the we can model the I beam as, let us say, 360 UB 44.7. So we can model this beam from this point to this point. We can again repeat this criteria here also. Yeah. So now modeling is done, and after that we can again go to the draw beam column brace, and we can go to the quick draw beam column brace option. In here, yeah, there's one more option: draw beam column brace and quick draw secondary beam option. So in here, we know that this spacing is approximately 6 meters, and we are dividing it with 500 mm. So we can select the number of beams here as 12. That is 12 into 0.500 is 6000 mm. So we can select the property here as C200 into 1.9, number of beams as 12, or what we can just say maximum spacing also. So maximum spacing we can divide it by 500 mm. So yeah, so now this is modeled here, and moment releases are pinned only. So we can repeat the exercise here also, and we can repeat the exercise here also. So now the secondary beams are modeled here, and we can go to the draw beam column brace option here. Here also we can again select C200 1.9 and moment releases as pinned. And again, we can model the beams from this point to this point. Right click, and then again left click from this point to this point. Left click from this point to this point, and then again right click to tell the software that we have modeled the beams and we do need to shift the cursor from one point to another point. So now the modeling is done, and we can just press Ctrl and W option on our keyboard. We can select the object assignment, and we can left click on end releases for under the frame assignments option. We can left click on apply and close. So now we can see that all of these, this is only the moment of the stunt frame, and the perpendicular direction, everything is the shear frame only. So after that, what we can do is that we can go to the plan, and we can left click on base option here, apply and close. And we can select all of the joints here. We can go to the assign joint restraint and select all of these as fixed restraint only. We can left click on apply and close. So as we know that, okay, so all stories option are selected. We can left click on like one story. We can just simply press Control and Z option. We can again go to the, or what we can do is that we can just simply click on rotate 3D view. We can select all of the joints here. We can go to the assign joint restraints and select them as fixed, apply and close. So now all of the supports are now fixed. And after that, what we can do is that we can select all of these joints here. We can go to the edit and we can go to the replicate. We can click on linear, and as you know that this is y-axis and this is a positive y because we want to make a cantilever of 1.5. So we can left click on dy 1.5 and apply and close. So we can press Ctrl and W again and then just untick the invisible option. So with that, all of the joints shall be visible. There's one more option. What we can do is that we can just simply undo replicate, because ultimately, what we have to do is that we have to model each and every beam. So to avoid that, there is a shortcut. Just simply undo this replication, go to the plan view, story one, close, and in here we can just select all of these joints here. Again, go to the 3D view and just simply, unselect these frames here. What we can do is that we can go to the plan view here, left click on story one, apply and close. Just select all of these frames here. We can draw a rectangle from right to left so that all of the frames are selected here. And then again we can go to the like press Ctrl and R option on the keyboard, that is replication option. We can select dy as 6, left click on apply. Sorry, the spacing is approximately 4.5, so we can select 4.5 here. So left click on apply and OK. So now we know that, in our case, the purlins are basically only 1.5 meter cantilever from this particular point. And in our case, we are getting approximately 4.5 meter. So what we can do is that we can select all of these joints here. We can go to the edit and move joints frame shells, and in here we can select y here as -3 meter. So we can left click on apply. So now we can see that our like modeling is done, but with 1.5 meter spacing. There's one more thing I'd like to do here is that I just like to remove the secondary releases here. There are two reasons for that. One reason is that purlin is getting rested on the top of this beam, so it won't be getting released here. So we can select all of these purlins here. We can go to the assign frame releases and partial fixity, and in here we can select no releases, apply and OK. So now we can say that our whole structure is like we do not have any kind of release here, because basically purlins are getting rested on the top of the steel beams. So what we can do is that we can go to draw beam column brace. You can just simply press close option here, and in here instead of the pin we can select continuous, and we can like model the there's one more shortcut here. Just simply model a beam from this point to this point, and we can go to the plan view here, story one and close. Sorry, the beam is not modeled correctly. Draw beam column brace, select C200 1.9, from this point to this point. Go to this option here. Select all of the joints also and the beams also. Go to the edit frames, divide frames, break at intersection of selected frames and joints. Apply and close. So now instead of a single beam from this point to this point, we do have small beams with breaking in between the secondary purlins. So now the modeling is done. So under the second case, what we can do is that we can apply the loading also. So for the loading, what we can do is that we can simply apply the equivalent loading either on these we can say hot rolled UV sections, or we can apply the loading here on the C purlins also. So that we shall discuss in the next lecture.